Question 1. When evaluating the merits of a refrigerant retrofit in an older residential system, HVAC technician Isa Delgado notes that the existing R22 condensing unit has a reciprocating compressor and a capillary tube metering device. The homeowner requests a conversion to R407 due to rising R22 costs. Isa Delgado explains that simply recovering R22 and recharging with R407 is not advisable. What is the most critical reason? A. R407 will increase suction pressure beyond safe limits. B. Capillary tubes are incompatible with blended refrigerants like R407. C. The system's oil must be changed from mineral to PO. D. R407 cannot be used with reciprocating compressors. Answer. Correct answer. C. Explanation. R407 is a zeotropic blend and requires polyester PO oil, not mineral oil used with R22. Without changing oil, the refrigerant will not properly circulate, risking compressor failure. ASHRAE guidelines and EPA section 608 emphasize that oil compatibility is essential when retrofitting systems. While cap tubes can work with blends, the oil incompatibility is the most immediate hazard. Question 2. Demonstrated by technician Mr. Hooper installing a new TSV-based split system. He pulls a vacuum down to 450 microns, then closes the valve and watches the micron gauge rise to 1600 over 10 minutes. What does this rise in pressure indicate? A. Micron gauge drift due to temperature. B. Residual moisture still in the system. C. The vacuum pump is undersized. D. The vacuum hose diameter is too large. Answer. Correct answer. B. Explanation. A pressure rise after isolation suggests either a leak or moisture boiling off. Since pressure steadily climbs to 1600 microns, this indicates desorption of moisture from surfaces. According to CARE and RSES evacuation best practices, pressure rise testing helps verify a deep vacuum and system dryness. The pump and hoses matter, but moisture presence is the most direct cause. Question 3. The fundamental question is, what is the purpose of reversing valve in a heat pump during the cooling season? A. It blocks refrigerant flow to the evaporator. B. It reverses compressor rotation for cooling. C. It directs high-pressure vapor to the indoor coil. D. It bypasses the outdoor fan. Answer. Correct answer. C. Explanation. The reversing valve redirects refrigerant flow based on mode. In cooling, it sends hot vapor to the indoor coil, now acting as the condenser, allowing heat rejection indoors. ARI and NATE manuals explain this flow reversal is central to heat pump operation. Compressor direction does not change. The only flow path is altered. Question 4. Given the circumstances where a Statista must install flexible ductwork in a low-clearance attic, he chooses a 12-foot section of uninsulated flex duct between two metal trunks. What factors should he prioritize to prevent airflow problems? A. Ensure the duct is tightly compressed. B. Use as many support straps as possible. C. Stretch the duct to eliminate kinks and sag. D. And a secondary fan to boost pressure. Answer. Correct answer. C. Explanation. Flex duct must be fully stretched to minimize static pressure losses. Sagging or compression increases resistance, reducing system performance. According to SMACNA and a CAM manual, D. Flex duct should be supported every 4 feet and installed tautly to meet airflow standards. Extra fans are unnecessary and can cause balancing issues. Question 5. The effectiveness of electrical troubleshooting often hinges on understanding the behavior of different components. Technician Isley measures 0 volts across a contactor coil in a system not starting. However, the coil has 24 when tested to ground. What does this suggest? A. The coil is open internally. B. The transformer is defective. C. There is a break in the low voltage common. D. The thermostat is shorted. Answer. Correct answer. C. Explanation. 24 to ground but 0 across the coil means one side lacks return common. This indicates an open or broken common leg. According to NEC and HVAC troubleshooting practices, RSES, a complete 24th circuit requires both hot and common. A missing common prevents coil energization even with apparent voltage. Question 6. In light of recent developments, technician Mr. Santos is brazing a new condenser line set using nitrogen flow. Another tech suggests skipping nitrogen to save time. Mr. Santos refuses. Why is nitrogen purging necessary during brazing? A. It prevents pressure buildup in the tubing. B. It keeps the refrigerant oil stable. C. It prevents oxidation inside the tubing. D. It improves thermal conductivity. Answer. Correct answer. C. Explanation. Brazing without nitrogen allows oxidation inside tubing, forming carbon flakes or scale that contaminates the system. These can cut ESVS and reduce heat exchange. EPA Section 608 and ARCE's brazing guidelines emphasize nitrogen flow to maintain internal tube cleanliness and prevent long-term failures. Question 7. During the process of installing a split system, Green finishes the line set and proceeds to evacuate the system using a single hose connected to a Schrader valve. The system takes over 2 hours to pull below 1,000 microns. What is likely causing the slow evacuation? A. The vacuum pump is oversized. B. Using only one access port reduces conductance. C. Oil is holding excessive moisture. D. The suction line is too large. Answer. Correct answer. B. Explanation. Using a single Schrader port restricts flow and increases evacuation time. High conductance evacuation requires removing Schrader cores and using both suction and liquid lines with large diameter hoses. ARCE's evacuation guidelines and EPA best practices stress minimizing restrictions for efficient evacuation. Question 8. Based on the information provided, what is the main purpose of installing a P-trap in a condensate drain line connected to a fan coil in a negative pressure plenum? A. To allow air to vent from the trap during heating. B. To prevent sewer gas from entering the duct system. C. To stop air from being drawn into the drain line. D. To equalize pressure across the trap. Answer. Correct answer. C. Explanation. In negative pressure plenums, air can be drawn into the unit via the drain line, causing gurgling or overflow. A P-trap holds water that blocks airflow, ensuring proper drainage. IMCANUC codes mandate traps on condensate lines in such situations for safety and hygiene. Question 9. Through careful analysis of voltage readings, technician Reed finds that the furnace transformer is overheating and tripping its internal thermal breaker. He measures 20 ATV output instead of the expected 24. Which issue is most likely the cause? A. The thermostat has too low resistance. B. The primary voltage is too high. C. The transformer is oversized. D. The transformer is grounding out. Answer. Correct answer. B. Explanation. If the primary voltage is significantly higher than rated, the transformer secondary will exceed expected voltage, leading to overheating. NEC and NEMA transformer guidelines state that transformers must be rated for actual incoming voltage to prevent overheating and premature failure. Output alone doesn't confirm overload. Input must match spec. Question 10. The correlation between airflow and heat transfer efficiency is critical during equipment selection. When an installer like his Novak sizes a return duct system for a 3-ton air handler, what static pressure drop value across the filter is considered acceptable according to industry standards? A. 0.30, B. 0.75, E. 1.0, E. 0.10. Answer. Correct answer. A. Explanation. Standard residential systems are designed for a total external static pressure of around 0.50. Filters should not exceed 0.30. As per a CAM manual, the ANRI system performance standards. Higher pressure drop results in reduced airflow, loss of capacity and motor strain. Question 11. While examining a rooftop package unit installation, Mr. Patel notices that the unit's condensate drain is routed horizontally for over 12 feet before reaching vertical drop. The unit has negative pressure in the evaporator coil section. What installation detail is missing that could cause water backup and overflow in this setup? A. Condensate pump for added lift. B. An air admittance valve at the end of the run. C. Properly sized P-trap with vent. D. Slope of 1-2 inch per foot. Answer. Correct answer. C. Explanation. Long horizontal runs on negative pressure drain systems require a P-trap to prevent air suction, which can disrupt flow and cause overflow. Event may be required on the outlet side. Inc. 3072-2 states that trap shall be installed on the condensate drain line when the equipment is installed in negative pressure environment. Pumps or slope alone won't solve this issue without the trap. Question 12. From the perspective of duct system design, Istakline installs a high-efficiency air handler with a variable speed Ecker motor. He observes high static pressure and excessive noise from supply registers after startup. What is the most probable cause based on airflow principles? A. The return duct is oversized. B. The supply duct system is undersized. C. The filter is missing from the cabinet. D. The refrigerant is overcharged. Answer. Correct answer. B. Explanation. Undersized supply ducts create high resistance, causing excessive static pressure and velocity noise. Ecker motors maintain airflow by increasing torque, potentially masking undersizing issues until symptoms appear. The CAM Manual D and ARCES guidelines stress proper duct sizing, especially with variable speed equipment, to prevent system noise and inefficiency. Question 13. According to recent studies, technician is Wilkins wires a 3-wire, single-stage heat-cool thermostat to a gas furnace with a 24-volt control circuit. After turning the system on, the cooling system runs continuously and ignores thermostat commands. What wiring mistake is most likely responsible? A. The common wire is missing. B. The W and Y wires are reversed. C. The R and C wires are shorted. D. The jumper between R and RC was left in place. Answer. Correct answer. D. Explanation. Many thermostats require removing the jumper between R and RC when using separate transformers for heating and cooling equipment. Leaving the jumper in creates backfeeding and can cause unintended operation. NEC and manufacturer wiring diagrams recommend verifying transformer configuration and proper isolation between circuits to prevent malfunctions. Question 14. A detailed analysis of airflow across an evaporator coil reveals significant frost accumulation after 20 minutes of operation. Technician Istanuan verifies the refrigerant charge is correct and the blower motor is running. What should he check next to resolve the issue? A. The suction line insulation. B. Return grill spacing and velocity. C. Air filter cleanliness and airflow restriction. D. Compressor amperage draw. Answer. Correct answer. C. Explanation. Insufficient airflow due to clogged filters or blocked return paths leads to low coil temperature, resulting in frost. Even with correct charge and fan operation, poor airflow impedes sensible heat absorption. CAM Manual S and ARCES service protocols emphasize verifying clean filters and unobstructed airflow paths before suspecting refrigerant issues. Question 15. A contemporary view of refrigerant safety emphasizes environmental impact and flammability. When selecting a refrigerant like R32 for a new residential mini-split installation, which factor must be addressed during installation that differs from legacy R22 or R400 TINA systems? A. Oil compatibility with PO. B. System must be retrofitted for higher pressure. C. Adequate ventilation and leak detection due to flammability. D. Use of a suction line accumulator. Answer. Correct answer. C. Explanation. R32 is classified as mildly flammable under ASHRAE 34. Installers must follow updated safety standards such as IL 60335-240 and local code amendments for leak detection, ventilation, and system isolation. Pressure and oil requirements are similar to R400 TINA, but flammability handling is new regulatory focus with emerging refrigerants. Question 16. In comparison with traditional single-spud PSC motors, why might a variable speed Eck and blow motor require specific dip switch or programming setup during installation? A. To prevent short cycling during dehumidification. B. To match voltage fluctuations from the power supply. C. To prevent reverse rotation on startup. D. To adjust CFM based on system tonnage and duct design. Answer. Correct answer. D. Explanation. Ecker motors require configuration via dip switches or setup interface to provide correct CFM for system size. Improper setup may result in under or over ventilation. Per OER specs and NATE training, installers must match airflow programming with the equipment's tonnage and expected static pressure. These settings directly affect comfort and capacity. Question 17. When considering safety compliance, Mr. Jefferson installs a gas furnace in a residential basement. He routes the combustion air intake within 2 feet of the gas meter and installs the vent termination directly above. A sidewalk. What code violations are present in this setup? A. Only the intake location violates clearance codes. B. The vent must be 3 feet above grade and 3 feet from any meter. C. Combustion air and vent must terminate at roof level only. D. There are no violations if the intake has a screen. Answer. Correct answer. B. Explanation. Per NFPA 54 National Fuel Gas Code and manufacturer instructions, vent and combustion air terminations must be at least 3 feet from gas meters and other utilities. Also, terminations cannot be placed where exhaust could pose a hazard. Like above sidewalk, these clearances ensure safety from flue gas re-entry and physical obstructions. Question 18. From a practical standpoint, why is it critical for Mr. Thomas to properly torque flare fittings when installing a ductless mini-split system using R400 TINA refrigerant? A. To ensure electrical bonding between piping and unit. B. To eliminate pressure drops at joints. C. To prevent microleaks under high pressure. D. To align refrigerant flow across the distributor. Answer. Correct answer. C. Explanation. R400 TINA operates at much higher pressures than R22. Improper torque on flare connections can cause microleaks that may not show up immediately. Using a torque wrench ensures gasket deformation is within spec. Per manufacturers and RSA's best practices, over tightening or under tightening is a major cause of refrigerant loss and callbacks. Question 19. The underlying principle of electrical circuit protection in HVAC systems is to protect wiring from overheating. If Is Bernard installs a 10-ohm conductor for a 240 heat strip drawing 25 amps, what breaker size should be used per neck? Guidelines. A. 40 amps. B. 25 amps. C. 35 amps. D. 30 amps. Answer. Correct answer. D. Explanation. According to NEC Table 310.16, 10-ohm copper wire is rated for up to 30 amps. Installing a larger breaker risks overheating conductors and violates code. Breaker sizing must match conductor ampacity, not just equipment load. NEC 240.4b allows certain rounding for motor loads, but wire protection is paramount. Question 20. In the context of system commissioning, Mr. Yusuf completes a startup checklist for a newly installed split heat pump system. While checking refrigerant charging cooling mode, he finds 10 deg subcooling and 24 deg superheat. Ambient temperature is 9 deg. What is the most accurate assessment of this data? A. System is overcharged. B. System is undercharged. C. Charge is within normal parameters. D. The TXB is stuck closed. Answer. Correct answer. B. Explanation. Normal subcooling for R400 TINA systems is 812 deg and superheat is ideally 815 deg in TSB systems. High superheat 24 deg with nominal subcooling indicates undercharge. Too little refrigerant causes excessive vapor at the outlet of the evaporator. Per OEM guidelines and RSA's charging procedures, this system needs more refrigerant. Question 21. At the advent of modern high-efficiency systems, Mr. Rollins is tasked with installing a condensing gas furnace in a sealed attic space. To meet manufacturer and code requirements for combustion air, he installs 2 PVC pipes to the outdoors, one for intake and one for exhaust. During inspection, the OJ fails the job due to pipe placement. What is the most likely reason for the failure? A. The exhaust pipe is too far from the intake pipe. B. The intake and exhaust terminate in different pressure zones. C. The intake is sloped downward toward the furnace. D. The intake and exhaust are made of Schedule AE. Answer. Correct answer. B. Explanation. Per NFPA 54 and manufacturer guidelines, intake and exhaust terminations must be in the same pressure zone to ensure balanced airflow and proper combustion. If they terminate on different walls or levels, pressure differences can disrupt combustion or cause flue gas recirculation. Slope and pipe material aren't typically code violations in this context. Question 22. Taking into account airflow requirements is Lyons installs a return grille near the floor in a 3-ton system. After startup, occupants complain about uneven temperatures and frequent cycling. Manual J confirms correct sizing and refrigerant charge is verified. What most likely caused the issue? A. The return grille is too close to a supply register. B. The return grille is undersized for system capacity. C. The return is located on an outside wall. D. The return grille is installed without an isolation box. Answer. Correct answer, B. Explanation. Undersized return grilles can restrict airflow, resulting in high static pressure and poor circulation. Even with correct charging capacity, inadequate return airflow affects temperature distribution and causes short cycling. A CAM manual D emphasizes matching return grill free area to blower airflow, typically 2 CFM per square inch. Question 23. What factors contribute to high-pressure cutouts during heat pump operation in heating mode when outdoor ambient temperatures are moderate, but indoor airflow is restricted? A. Excess refrigerant charge in the accumulator. B. Undersized supply ductwork limiting heat rejection. C. Improper reversing valve orientation. D. Suction line restriction due to oil logging. Answer. Correct answer, B. Explanation. Restricted indoor airflow leads to high head pressure because the system cannot reject heat effectively. During heating mode, the indoor coil acts as the condenser. Undersized or restricted ductwork reduces airflow, increasing coil temperature and causing the high pressure switch to trip. A CAM manuals D and S both stress proper airflow design for heat pump performance. Question 24. As evidenced by Mr. Carmichael's installation of high-efficiency air conditioning system with TXV metering device, he observes pressure drop across the liquid line filter dryer of 8 side during cooling mode. What is the best interpretation of this reading? A. The system is overcharged. B. The dryer is contaminated or partially restricted. C. The compressor discharge valve is leaking. D. The TXV is stuck open. Answer. Correct answer, B. Explanation. A pressure drop greater than 2/3 psi across liquid line filter dryer typically indicates partial restriction, often from moisture or debris. Filter dryers must be replaced if clogged, as they affect subcooling and refrigerant flow. ARCES and Emerson guidelines highlight 8 psi as critical point requiring service or replacement. Question 25. Under the assumption that correct superheat and subcooling readings are observed, yet the indoor coil is frosting up during operation, what installation-related issue is most likely the cause? A. The TSV is set too low. B. Return air filter is missing. C. Blower speed is set too low. D. The defrost control is malfunctioning. Answer. Correct answer, C. Explanation. Even with proper refrigerant charge, insufficient airflow across the evaporator coil leads to coil surface temperature dropping below freezing, causing frost. This is often due to low blower speed, dirty blower wheel, or restricted ductwork. Per CAN OES specifications, airflow should be at least 350,400 CFM per ton of coolant. Question 26. Throughout the course of a furnace installation, Mr. Becker forgets to install a sediment trap on the gas supply piping to the unit. What is the purpose of a sediment trap and why is its omission a code violation? A. It stabilizes gas pressure during ignition. B. It filters out carbon monoxide before combustion. C. It collects moisture and debris before reaching the gas valve. D. It limits gas volume to avoid overfiring. Answer. Correct answer, C. Explanation. A sediment trap or dirt leg collects particulates, oil, or moisture in the gas piping before reaching sensitive components like the gas valve or burners, required by the IFCAN in FPA 54 Sec 967. Its omission risks contamination, leading to flame instability or valve failure. It has no role in pressure regulation or combustion gas filtration. Question 27. In a modern context of mini-split installations, Tran is installing a ceiling cassette unit where the condensate pump is located above the unit itself. What precautions should she take during installation to prevent backflow and overflow? A. Install a check valve downstream of the pump. B. Use larger diameter tubing for the pump outlet. C. Install a vent loop above the cassette. D. Route the discharge line directly to a floor drain. Answer. Correct answer. A. Explanation. When condensate pumps are located above the drain pan, backflow due to gravity can overflow the cassette if a check valve is not installed. Manufacturer guidelines in Inc. 307 recommend installing check valves in elevated pump discharge lines to prevent siphoning. A simple floor drain doesn't solve vertical lift or siphon issues. Question 20. A key distinction between thermocouples and flame rectification sensors in gas furnaces lies in their method of flame verification. What makes flame rectification sensors more suitable for modern electronic ignition systems? A. They measure the color spectrum of the flame. B. They detect DC microamp current flow through flame. C. They measure radiant heat from the flame. D. They complete a 24th circuit only when preheated. Answer. Correct answer. B. Explanation. Flame rectification sensors work by detecting a small DC current conducted by the ionized gas of the flame. This current signals to the control board that the flame is present. This method is fast, reliable, and compatible with electronic ignition systems. Thermocouples use heat to generate millivolt signals. Too slow for modern systems. Question 29. During the process of equipment startup, Mr. Aguilar notices that the compressor amps are significantly lower than the relay on the nameplate, even at full cooling load. What is the most appropriate conclusion? A. The compressor is undercharged. B. The system is operating efficiently under low load. C. The suction pressure is too high. D. The wrong capacitor is shorted. Answer. Correct answer. B. Explanation relays the maximum continuous current the compressor can handle, not what it must always draw. Low amp draw under low cooling load, e.g. mild outdoor temps or short runtime is normal. As long as pressures and temperatures are within spec, the system is running efficiently. ASES cautions against assuming issues from low amp readings alone. Question 30. Scholars have debated whether airflow adjustments alone can resolve latent cooling problems. What adjustment is most appropriate when an HVAC system is removing insufficient humidity in cooling mode? A. Increase airflow to reduce coil temperature. B. Decrease blower speed to extend contact time with coil. C. Raise refrigerant charge to increase coil frost. D. Install a bypass damper in the supply duct. Answer. Correct answer. B. Explanation. Lowering blower speed increases air contact time across the evaporator coil, enhancing moisture removal. High airflow reduces latent capacity by minimizing dehumidification. CAM Manual S and NATE training suggest airflow adjustments as a valid way to balance sensible and latent performance. Overcooling or improper refrigerant adjustment worsens humidity issues.